So in 11.2 we talked about slope fields, and one of the things that we did with the slope fields was sketch some solution curves by just kind of following those arrows along the slope field to get us to the next points. In this video we're going to discuss a method called Euler's method that will allow you to kind of systematically sketch a curve of the solution. So here's the idea. Suppose I'm on a line with a slope of 2 at the point 3, 7. How would I find the y-coordinate of the point with x-coordinate 3.3? The way you compute this is that the change in y equals the slope times the change in x. So my change in y, which we're going to call delta y, equals the slope 2 times the change in x. Well, I'm going from 3 to 3.3, so I'm increasing x by 0.3. So I'm going to expect the change in y to be 0.6. If y was 7, the new y is going to be 7 plus the change in it, 0.6. The new y is going to be 7.6. So what we're going to do is we're going to actually use slope, and we're going to systematically sketch some curves to a differential equation. So let's consider the differential equation dy dx equals 2xy. That's saying the slope equals 2 times the x value times the y value. Use Euler's method with delta x, or our change in x, being 0.5 to estimate y when x equals 2. For the solution curve through y of 0 equals 1. So that's essentially just giving us a starting value that x is 0 and y is 1. And we want to find y when x equals 2. So we want to work this all the way through to get x equals 2. So let's start first by finding our change in y. So delta y for this first one is going to equal the slope, which is 2xy. So 2 times 0 times y times our change in x, 0.5. So here, delta y is going to be 2 times 0 times 1 is 0 times 0.5. Our change in y is 0. So the next y-coordinate, if we started at 1, we're going to change it by 0. The next y-coordinate would be 1 plus 0 is 1. Alright, so let's move on. We're going to change x again by 0.5. So we're going to jump from 0.5 to 1. So delta y is going to equal 2 times the x-coordinate is 0.5 times the y-coordinate, which is still 1, times the delta x, which is 0.5. So we get 2 times 0.5 times 1. That's actually 1 times 1 is 1. Times 0.5. Our delta y is 0.5. So now to get our y, we're at 1. And we're going to add to it 0.5. Y is going to be 1.5. Moving on, let's find the next y-coordinate. Delta y is going to equal 2 times x times y times delta x is 0.5. So we've got 2 times 1 times 1.5. Right, that's really 3 times 0.5. That gives me the change in y is 1.5. So the next y-coordinate, we're at 1.5 plus 1.5, which is really 3. Continuing on, and this is going to finish it. This is going to get us to x is 2. The change in y is going to equal 2 times x is 1.5 times y is 3. All that times our delta x is 0.5. So we get 9 times 0.5. This is really 4.5. So 3 was where we were at. We're adding a change of 4.5 actually gets us to 7.5. So what I'm saying is these points over here would map us along the solution curve. So I've given you the slope field. This is the slope field for dy equals 2xy. And so let's see what happens when I graph these points. 0, 1, 0.51, 1, 1.5, 1.5, 3, and 2, 7.5. I'm saying those should be following this curve. So let's start at 0, 1, which is right here. The next point we have is 0.5, 1, would be approximately here. The next point is 1, 1.5. The next point is 1.5, 3. And the next point would be 2 and 7, so somewhere like way up in here. If you notice, look at how that graph actually follows those arrows. So the Euler's method is following the slopes in our field. And if we wanted to just kind of complete this sketch, we would probably say it looks something kind of like this.